Okay, year 11. Let's have a look at the next topic that we're doing, or the next part of the topic that we're doing, which is bearings. Now, I just want to have a look at the syllabus guidelines. So I've gone to the NESA website, which you can go to, right? You can go to the NESA website. You go and look up the maths syllabus. Now, even though you can download this, and I've done this, I've downloaded it, it's better because sometimes they can make slight changes. They have to notify us if they make changes, but they can make changes. And if you're going to the website and looking at the syllabus and the syllabus dot points, you know you will always have the most up-to-date version, bit of version control. So here we are in the trigonometry section. And what I want you to have a look at is the 5th dot point down here for trigonometry T1.1, solving practical problems involving Pythagoras' theorem, the trigonometry of triangles, which may involve the ambiguous case. I'm going to talk about that in a minute. Next lesson, including finding and using angles of elevation depression. We did that last lesson. And using true bearings and compass bearings. Now, the reason I've highlighted that, or want you to understand that, is most of the time we just use true bearings, but they've put compass bearings in there, so we will need to make sure we understand what compass bearings are. Now, here we are back at the textbook, and there is compass bearings. Now, we don't tend to use compass bearings much anymore, but a compass bearing, look at this, it always happens with this, this thing here, look at that says 70. That should be northeast. Anyway, so when you draw diagrammatically your compass, you just put your 4-star compass, and you have north and south and east and west. Now, if you put in, you can go an 8-star compass, and you can even go a 16-star compass. But here we get northeast, and we get southeast, and we get northwest, and we get southwest. Now, and because these are all done equally, that's 45 degrees, that's 45 degrees, and all of these ones around here are also 45 degrees because it's got to add up to 360. So you can do another one, so you could do another line in here that splits this here, and this is northeast. And then you could split this one here, and you could get east, northeast. And that'd be 22.5 degrees. But I don't think they're going to ask you about the 16-star compass. I think they'll leave it at the 8-star compass. Now, how do we call a compass bearing? Well, a compass bearing is always, and you need to write these in your notes, a compass bearing, to give a compass bearing, and write this down somewhere, it's always an acute angle so you write an acute angle from north or south all right, going east or west. But use a capital for my east. So, if we go down here and have a look at some of these questions, and in question 1, they got draw a diagram, north 50 degrees east. So question 1A, always draw your north, put a dot there, and then you go 50 degrees this way, because east is, because that's north, and east is over here, and that's north 50 degrees east. Now, you don't have to be accurate. You don't have to do it with a protractor. That's the only thing you're trying to do. Let's have a look at another one. I want to do a south. So south 60, let's do B. South, B is south. So I'll put a dot. I go down here to south. And what was it? 60 degrees west, I think. 60 degrees. So remember, west is over here. So I've got to go 60 degrees that way. And remember, not a protractor, but a reasonable diagram. Let's have a look at how they can ask us a question with compass bearing, or here they give us, they ask us to find the bearing of one thing from the other, and I'm going to talk about this here. Whenever you're asked to find the bearing of X from Y. So back up here in your notes, because we are going to talk about true bearings. For the bearing, and this is important, of A from B. You need to think. Of is where you're standing. From is where you're standing. You've got to pretend that you're standing wherever it says from. You're standing, and of is what you're looking at. Oh, that. So the bearing of A, that's what I'm looking at, from B, where I'm standing. If you remember that. So if I had the bearing, so if I go down here and have a look at these ones. The bearing of X from Y. Well, that means here, if I look at this one, that's where I am. And over here. Now, the common mistake here for question 2B would be to go, oh, that's north 10 degrees east. It's not. It's not 10 degrees east. It is north and east, but you need this angle in here because it's from north. So north, 80 degrees east. Now, if you have to give a compass bearing and it goes the other way around, let's imagine of X from Y. They're all pretty easy. Have they got a harder one? I'm going to try and find one that has a harder one. So when you're doing these, we're only doing the bearing questions, and I want to find a compass bearing question. And there aren't very many because they tend to be true bearing questions. True bearing questions. Okay, let's have a go at Robin. Okay, and I'm going to give this as a compass bearing. I'll come back and do Robin as a true bearing. So Robin starts at a house and walks 2.7 kilometres east. So let's draw her house. Here's Robin. That's a ridiculous house. And she's walking east. So she goes, she walks east for 2.7 kilometres. Sorry, she walks south first. So here she goes. She walks south. for 2.7 kilometres. And then she walks east for 1.6 kilometres. So there she is. She's walked all this way and she's all the way over here. And it says, what is her bearing from the house? Okay, so I have to work out her bearing from the house. So I have to work out this angle in here, because her bearing is going to be south, that angle east. Right? That's her bearing as a compass bearing. I'm going to come back to this question and work out her bearing as a true bearing. We'll do that later. So I've got to work that angle out. So if someone said, oh, Robin's lost, where is she? Oh, she's south, whatever that angle is, east. She's on a bearing of south. If you walk on a bearing of south, whatever the angle is east, you'll run into Robin. Okay. So how am I going to work that angle out? Well, I've got a right angle triangle here. I'm going to have to use my trig, my right angle trig. I'm going to call that angle theta. And we go tan, I'm going to get into black first, tan theta equals opposite 1.6 over 2.7. Theta equals inverse tan 1.6 over 2.7, and then I pump out my calculator, inverse tan 1.6 divided by 2.7, and I'll get that in degrees, minutes and seconds, so 30 degrees, 39 minutes, 30 degrees, 39 minutes. And what question is this? Because 24, and I know that's right because I've seen the true bearing. So her bearing is south 31 degrees east. So we've got a from north or south acute angle. So they're compass bearings. All right. Now, I've sort of gone over them quickly because one we really want are true bearings. Now, the reason we use true bearings is when you're saying letters, like imagine if you're in the emergency services and you're saying letters and numbers, it can get quite confusing, and they wanted to simplify the whole process. So true bearings, because if you're working on a radio and it's an emergency situation and you know, and you're trying to listen for the bearing of something, all you want is to hear three numbers. So a true bearing is a 3-digit number taken clockwise. Now, if you're a digital person and you don't know what an analog clock is, I'm going to show you. Clockwise from north, and it's always from north. So whenever you do this, you draw your north, and clockwise just means this direction, the way the hands of a clock go. So you're always going to go that way. So let's go and have a look at this. And we go down to question 1. And how do we do these true bearings? So first of all, 1E. A boat is on a bearing of 100 degrees. First thing, draw your north. So this is where you're starting. Draw your north. And I go 100 degrees. Now, you need to know with your notes of true bearings about, and I put this in my notes, about how far certain things are around. So if that's 0 degrees and that's north, well, you should know that 90 degrees will get me here. 180 degrees will get me to here if I'm going this way. Remember, there's 90, there's 180. There, what will that be? Well, that'll be another 90 degrees. And you need to know that that's 270 degrees until you get all the way back up to where you started, and will be 360 degrees. So you need to know 90, 180, 270. So if I go back down here to this one, and I had to draw 100 degrees, well, I know 90's straight across, so I reckon 100 degrees will be about there. And there is my 100 degrees. Now, it doesn't have to be protractor accurate, but it does have to be in the right realm. Let's do one more. Let's get one of these big ones. Let's get 285. A plane is on a bearing of 285 from Broken Hill. Plane is on a bearing. So this is I. So I go I. Draw a north. That's your first thing. North, put a dot. It's a bearing of 285. Well, I know that that's 270. So if I go all the way around here, that's 270. I have to go a bit more. So my bearing is going to be there. And that is 270. Was it 270, 275? 285. Degrees. Now, you should be able to work out what this angle is in here. It's 360 minus 285. And I'm going to the calculator for that because I made a stupid mistake in one of my earlier videos and I don't want to do it again. Minus 285. And that's 75 degrees. And finding these angles is all important. Okay. So there's two of those. Let's have a look at these ones. Remember, we had to give the true bearing. All right. So I'm going to do 2A and 2B. So I'll do 2A here. Now the compass bearing here for 2A is quite easy because it's south. It's south 35 degrees east. But to do the true bearing, I have to go from north. I have to work that out. And to work that out, it's 180 minus 35. So 180 minus 35. So it's true bearing, 3 digits, 145 degrees. Let's double check that. Yep. So that's the answer to 2A, 100. Now, and then some people write a T after that to indicate that it's a true bearing. This one here, 2B, the true bearing, oh, well, I just have to find that angle. Well, I've already found it. It's 80. So it's 80 degrees. But remember, you need 3 digits. So 0, 8, 0, true bearing. All right? You've got to have 3 digits. Let's go and do a question that involves a bearing question. I will do 24. Well, I'll do it now because it's quite easy. Remember, we had to find the bearing of Robin from the house. Now, to do that, I need a north. So there's my north, and the true bearing is this angle here. Now, we used tan to find the angle in there, and we got theta equals 30. So the true bearing is 180 minus theta. And that is, and we use the rounded version, 180 minus 31, which is 141 degrees. And that is the true bearing, 141 degrees, true. And I know that's the correct answer. Let's do one more. Let's do one where we have to draw a bearing and find the bearing back. They're always really good. They're always difficult. How far south? From the depot. I'm looking at question 28. Depot has train tracks running north and then another set of tracks going east. What is the bearing of the depot? Of the depot from the station. That looks like a good one. Let's do 28. So here's question 28. A train depot has tracks running 7-8 kilometres north and then east. So here's my depot. And these tracks run north, and then another set of tracks go east. And what are they? 7.8 and 5.8. So 7.8, 5.8. And there's the train station. That's where the station is. Now, you're good, Charles? Now, the question says, and this is where you've got to be really careful, what is the bearing of the depot, that's what you're looking at, of the depot from the station. So you need to draw your north there because that's where you're standing and you're looking back here. And to find the bearing, you have to find this angle. And you can find this angle, which I'm going to call theta. And because we know it's 270 all the way to there, do you remember that little diagram I drew? If I can find that angle, I can subtract it from 270. Now, this is a right angle, so I'm going to go tan theta equals opposite 7.8 over 5.8. And again, I'm going to go inverse tan 7.8 over 5.8 equals, calculator, shift tan 7.8 divided by 5.8. And I get 53 degrees. I hit my bubble button. 53 degrees, 22 minutes, which is 53 degrees if we're just going to the acute, which is what I bet they do. Now, the bearing is 270 degrees minus 53 degrees. So I'm going to go 270 minus my answer. And that gives me 216 degrees and 38 minutes, which is 217 degrees. And that's the correct answer. So there's a lot of things involved there. You have to do your right angle trig, you have to get your diagram right, and you have to realise what are they asking. And remember, the bearing of is what you're looking at, the bearing of the depot, from the station. That's where you're standing. So I'm pretty sure you should be right at those. I might do 22. Because it's a bearing question. It's reasonably easy. A plane leaves Sydney and flies for 2,000 kilometres on a bearing of 195 degrees. How far south is it of Sydney? So here's question 22. So I'm drawing a bearing 195 degrees. 195 degrees. Well, I know that straight down is 180. So 195 is going to be about down here. So here's my plane. This is where it's flown to. And it went 2,000 kilometers. Now, what do I have to find? So that's my north. And I know that this angle is 195 degrees. So this angle in here, theta equals 195 minus 180, which is 15 degrees. Now I have to find how far south. So here's the airport. Here's the airport up here. I have to find this, so I'm just going to call that X. So now what have I got? Well, I know this is 15, and I've got my adjacent and the hypotenuse. So I'm going to go cos 15 equals adjacent X over hypotenuse 2,000. So I go 2,000 times cos 15 equals X. Calculator, 2,000 times cos 15. 1,931.85. 1931.85 ... kilometers equals X. What do they want it to the nearest? 22. How far south? They don't say. If they never say, you always go to the same measurements they gave. So we'll go to the nearest kilometre. So 1932 kilometres is X, is how far south. And they went to one decimal place. So they went 1931.9, which is exactly what we got. So it's all good. Anyway, that's bearings. You really need to work at this because it's going to get harder when we involve different rules. Good luck.